Okay, let's start by measuring the BT137. For the measurement, we'll use the pinout of the BTA41, which has the same pinout as the rest of the Triacs. First, the gate. The measurement will always be taken between the gate and the other inputs, or power output terminals, A1 and A2. Now, we apply positive voltage to the gate, and it should measure us between A1 and A1. It should also measure us if we turn it upside down. Notice that the measured value is the same or very similar. See the value when you reverse them. Now, between the gate and A2, there should never be a reading. It doesn't matter if I reverse the probes. It still doesn't read. And let's confirm the tab topic. Terminal 2 and the tab should be connected. And there we can see that they are indeed connected or short-circuited. Okay, now take into account the measurement we made between the gate and A1. The value observed is similar to that of a diode. Let's see if other triacs show the same value or if they are different. Now, in the case of the BTA16, we should have a value between the gate and A1. And we can observe that the value is much lower than in the case of the BT137. This indicates that this one requires more energy to operate. It's like having a resistor with a lower value, and therefore, more current will have to flow. We take the measurement by inverting the probes, and we get the same value or a very similar value. And again, there shouldn't be any reading between the gate and A2. We reverse the probes, and it doesn't measure anything. Now we test between A2 and the tab. There should be no continuity, and there is no continuity. That's the advantage of the BTA16 Triac or the BTA series. They don't have that continuity problem, since that way I can use a heatsink to which I can connect both the Triac and other components. For example, a transistor, if it requires a heat sink, I can use the one from the Triac. Now let's look at the larger one. And speaking of the BTA41, unfortunately I don't have it at the moment, but I have the BTA26, which is very similar but with a lower amperage. We have the gate, A2, and A1. There should be a reading between the gate and A1. As you can see, the more power the Triac handles, the lower the value measured by the multimeter will always be. It's like a resistor. If you want to handle more current with the Triac, then the resistance it offers must be lower. Therefore, the same applies to this Triac. It has a value much lower, or slightly lower, than the BTA16. And between the gate and A2, it shouldn't register a reading regardless of polarity. And between A2 and the tab, it shouldn't register a reading either. Very well, taking this data into account, supposedly the BT137 should handle less current or require less current to operate. And so on for the rest of the Triacs.